How are you doing? This is Akash Mankani, and I am presenting to you a topic called cellular transportation. This is a very important topic in biology because it involves how things move in and out of cells, and this is critical when it comes to surviving. When it comes to playing basketball or football, all of the cells in your body have to be healthy. So cellular transportation is extremely important when you take this into mind. Now, there's different types of cellular transportation. In this presentation, we'll go into those. Once again, my name is Akash Mankani, and it is my absolute pleasure to deliver you the best presentation today. So, first of all, how do large and charged molecules enter the cell? Well, this involves a very, very important term called cellular transportation. This is how cells like oxygen can get in the cell, or water, or carbon dioxide. Let's move on to the next slide. So, in cellular transportation, this is a process where molecules are moved in and out of the cell, from one side of the cell membrane to the other. There are two types of cellular transportation. You have active transport and passive transport. Now, before I go into what active and passive is, take a look at the picture to your bottom right. So you have one individual who is both of these individuals are investors. One individual has an arrow, she has a globe, she's reading charts, she's looking at a bar graph, it looks like, while the other investor is looking at a clock. Now, if you take this into terms of a cell, the passive transport would be the guy exerting no energy, not doing anything to work hard, and by looking at a clock. The active transport would include the person using 6 hands to do a task, because that person is exerting energy, that person is enthused about what she is looking at. It looks like a she to me, I can't really tell from here. So you have two types of transportation, active and passive. Let's move on to the next slide, and if there are any questions, I'll take them at the end of the presentation. Okay. Hang on. Before we move on to the next slide, I just wanted to inform you that slide should be coming up. The two types of transportation, in the active and the passive transportation, you essentially one is using energy and one is not. And the words themselves tell you about active and passive transportation. Now let's look at passive transportation. It does not require energy. It moves molecules from high concentrations to low concentrations. And an example is simply going down a water slide. I mean, this is a simple example because you're going from up to down, or running down a hill. In passive transport, you have two types. You have simple diffusion and you have gated channels. Now, in simple diffusion, the molecules can freely pass in and out of the lipid bilayer, you call it, the membrane that protects the cell. Molecules can go in and out freely, usually small molecules. Now, through gated channels, the molecules have to go through a gated channel. So it doesn't exert energy, but it has to go through a gated channel. Imagine a high-rise building in New York City that has a security guard. And even though there's more people outside the building than inside, you still have to go through that security guard or that gated channel to get inside the building. These are two types of passive transport that you will need to know for your test coming up. Now, you also have facilitated diffusion. In facilitated diffusion, it's still a form of passive transport, but it allows diffusion to occur faster. So imagine that same security guard in the building is not only allowing you in the building, but he's pushing you through the building. He's taking a taser and saying, if you don't run, I'm gonna tase you in the back. So you're running through the building. That is facilitated diffusion. It allows for diffusion to occur faster, and it allows for larger molecules to pass through the lipid bilayer. And an example of this is glucose transportation. This is something that you'll see later on as we progress through the unit. Now, just for some clarification, what you see there is a lipid bilayer. You have a hydrophilic head with a tail. Hydrophilic means that it is water loving. Alright, now let's move on to active transportation. This requires energy. It moves molecules from a low to a high concentration. It's like running up a hill. Let's see what kinds of active transportation there are. So you have protein pumps, and what protein pumps are is an example of sodium-potassium pump. It is a popular pump in the heart cell. It pumps more energy out and it creates an imbalance. That is active transportation. You're using energy. Now, you have there's two ways to allow things into the cell and out of the cell. You have exocytosis and endocytosis. These allow for the passage of food particles and waste particles in and out of the cell. In endocytosis, the membrane folds and forms a vesicle. The contents are digested by cellular enzymes. An example of endocytosis is eating. You're cupping the food and then you're digesting it. It forms a cupping suction cup, and it engulfs the food essentially. Now you also have exocytosis. Now exocytosis, which is essentially the opposite of endocytosis. Instead of moving things inside, you're kicking things out. And in exocytosis, a substance is packaged into a vesicle, which is like a little bubble. The vesicle fuses with the plasma membrane, and the substance is released from the cell. If you look at the bottom right, you see the plasma membrane and the vesicle leaving the cell, and it holds the stuff inside. Now, in conclusion, you have two types of transportation. You have passive transport and you have active transport. In passive transport, you have two types. You have cell diffusion, which is when cells move from a higher concentration to a lower concentration, and this can happen through a gated channel, or it can just freely happen through the lipid bilayer. And you also have facilitated diffusion. Now this is when the security guard is almost like threatening you. If you don't run, I'm going to taser you. So it's when you have to move faster. It's when something helps you move faster without the use of energy. Now, in active transport, you have three types essentially. You have active transport you have two types. And in active transport, you are moving something inside the cell or out of the cell through the use of energy. And the sodium-potassium pump is a very, very popular example of this in the heart. In the heart pumps out three sodiums and allows in two potassiums, creating an imbalance which will suddenly cause the heart to beat. Then you also have exocytosis and endocytosis, which is essentially allowing things in and out of the cell. I really appreciate you listening. I will now direct you to another presentation that will give you a simpler insight on how things move in and out of cells. Thank you, Dr. Lena, and the rest of this ESC class. Thank you. Hey guys, how's it going this morning? It has been a long weekend, and I hope we're all rested up and ready to learn some more. So, I wanted to recall how last week we briefly talked about a cell, and how a cell is the basic building block of all living organisms on Earth. By basic building block, I mean, if you take your hand, for example, and you break it down into the smallest component possible, that smallest component will be a cell. And vice versa, our hands are built of billions and billions of cells. And this just characterizes the importance of why a cell needs to be healthy in order for us to be healthy. In order for Alex over here to be able to squeeze that tennis racket tight and have a firm grip on the racket, or Chelsea to be able to play basketball and have the follow-through work out the way she wants it to, the cells in her hand and the cells in Alex's hand are really going to be very, very healthy. Now today we're going to talk about exactly how those cells get healthy. Well, why do you go out and eat McDonald's every once in a while? Or Chelsea, why do you go to Ruby Tuesday every once in a while? Exactly, so you can get some proteins and nutrients in your body. Good answer. Good job. Now, similar to the reasons that your body needs proteins and nutrients, your cells also need proteins and nutrients. Your cells get hungry too, and your cells, they need these proteins in order to be healthy and survive and function the way that they're supposed to. So, first, I want to talk about how proteins get into a cell and how proteins get out of a cell. And in order to do that, I just need you guys to imagine. Let's jump outside of the box. Let's imagine that this classroom over here is a cell, okay? And the walls of the classroom are the wall of the cell, which can be depicted by this beautiful circle you see here on the whiteboard. Now, if you want to bring something into and outside of this classroom, through what would you do that? How would you bring something in and out of this classroom? Through what part of the wall would you bring something in and out of? Chelsea, great answer. The door. Is there anybody else? Can anybody else think of anything else other than the door? That was a perfect answer. Tom, exactly, good job. The window. The window and the doors of the classroom are where you would bring something in and out of the classroom. Now the door of the cell, or the window of the cell, is what we call the protein channel. The protein channel is the part of the cell where proteins go in and proteins go out, depending on whatever the cell needs or doesn't need. Now, let me ask you another question. If Robert over here is going to take this pencil and bring it out of the classroom, while Michael and Sean are going to take this desk and bring it out of the classroom, who's going to make it out of the classroom faster? Anybody? Alright, Amanda, you've been quiet in the corner. I know that you can think of a reason of why Robert might be able to take the pencil out of the classroom faster than Sean would be able to take the desk out of the classroom. Because it's smaller? Perfect. Great answer. That was excellent, guys. Because it's smaller. Now, the smaller, the lighter the object, the easier it's going to be able to move inside and outside the classroom. Similar to a cell, the smaller the protein, the faster it's going to go into the cell versus the larger the protein. Because the larger protein is heavier and more bulky, and it just moves slower, just like that desk does. Now, we can think of this in another way. If David has a stack of 12 books, and he's trying to get to the Ravens game, while Michael has a stack of 2 books, and they're both racing after class to get to the Ravens game, who's going to get out fast? Who's going to get to the game faster? Exactly, David will get to the game faster because he has a lighter books. He has a lighter load of books. Only 2 books versus Michael's 12 books. Now, I just wanted to recall what we've done. Sean, what is the door of the cell? Perfect. The protein channel is the door of the cell. Now, can anyone tell me the relationship between the size of the thing going in and out of the cell and the speed that it goes in and out of the cell? Great answer, Michael. The bigger the thing, the bigger the protein moving in the cell, the slower it's going to move versus the smaller the protein. Now, I wanted to thank you guys for being such a great, captive audience, and do your homework, and if there are any questions, I will be here after class and also after school in order to answer your questions. Thank you so much, and have a great rest of the day. Alright, that is the end.